Hello everyone. This week we're going to really focus on slope again and talking about slope and how you see it in a graph, and then of course it still means the same thing. It's the constant rate of change, it's the m, it's the coefficient. But we're going to look at how you can find an equation from a graph, and we're also really going to focus on the graphs because we're going to talk about different kinds of slope that situations can have, and I want you to remember to always try and relate that back to a real life situation. So here we go. It's types of slope and finding equations from graphs. So these are the four types of slope. You can have positive slope, that looks like this. You can have negative slope, looks like this. You can have zero slope, looks like a horizontal line like this. And you can have undefined slope, which is a vertical line, straight vertical line. First, let's talk about undefined slope and zero slope. So this is a graph with undefined slope. And basically, this is a situation in which every single point that's on this line is at the same x coordinates. So this is 0, 0 over here, and this is negative 1, 0, and this is negative 2, 0. Every single x point on this line is at negative 2. So for instance, this is negative 2, 1. This is negative 2, 2. If I go down here, this is negative 2, negative 1. And this is negative 2, negative 2. All of the points on this line are at negative 2. All of the x's are at negative 2. And because of that, we say that the equation of this line is x equals negative 2. Okay, if you had a line that was right next to it, that was straight up and down, vertical like that, the equation of this line would be x equals negative 1. What would the equation of this line be? If I had a line right here, straight up and down, right here, what would the equation of the line be? Did you say x equals 1? If you did, you're correct, because the x coordinates for all the points on this line are 1. This is 1, 0, this is 1, 1. This is 1, 2, up here is 1, 3, down here is 1, negative 1. All the x coordinates are at 1. Okay, so undefined lines always have equations that say x equals. This is a zero slope line, and the difference between it is that it's not vertical, it's horizontal. It's like having a very, very easy bike ride where you're not going to be developing your quads a lot, you're burning little calories, but you're not burning hard calories because there's no uphills, there's no downhills, you're just kind of going steady and smooth along, zero slope, no slope. And in this case, all the y coordinates are the same. So let's look at this spot right here. This is, right here, this is 0, 0, this is 0, negative 1, this is 1, negative 1, this is 2, negative 1, this is negative 1, negative 1, and this would be negative 2, negative 1. All the y coordinates are negative 1, and therefore this line is going to have a y equal equation. If I put a line up here, right here, all the y coordinates are now 2, so this would have an equation of y equal 2. You don't see undefined lines and zero lines as often as you see the other two types, positive slope lines and negative slope, because in real life, most situations that are linear are either going to be positive linear or negative linear. We'll talk about that in a second when we go back over those. It's really important that you remember that undefined is vertical, and it's going to be an x equal, and 0 is horizontal, and it's going to be a y equal. Positive slope lines, if you look at the graph and you start at the left over here, and you go to the right, this line is rising. So from the left to the right, the line is rising up. That's why it has positive slope. So that would be a situation like your pay definitely would be a linear situation that's positive slope, because the more hours you work, the higher your pay. More hours, higher, more hours, higher. And as x increases, y increases. That's positive slope. It's rising. This is a line with negative slope. If you start at the left and you go to the right, the line is falling. Starting at the left I'm going to the right. The line is falling. You read from left to right, you write from left to right, and you read lines from left to right. So it's always important when you're writing the equation of a line, the very last thing you should do is double check to see, is the line falling from left to right, or is it rising from left to right, so that you can make sure that you put the right sign, plus or minus, in front of the M. Okay, let's look at how to write an equation for a line when all you have is a graph. Here's my graph example, and the red is the line I'm looking at. Okay, the first thing I have to do is find the slope of that line, because I know that the equation of a line is y equal mx plus b. M is the slope, or the coefficient. To find the slope, I have to use the slope triangle. I drew in the slope triangle, so I'm finding 2 points that are exactly on the grid lines. Here's negative 3, 3, and here's 3, negative 1. And I'm drawing a slope triangle. So this is my rise here, and then this is my run right here. So now that I have the rise and the run, and it's attached to this red line that I have, look, it looks like a right triangle here. That's what it's supposed to look like when I say put in a slope triangle. Now, the slope triangle doesn't do you any good unless you can count the rise and the run, and you have to be careful because, for instance, on this graph, every tick mark is 0.5. It's not 1. So this is 0, this is 0.5, this is 1, this is 1.5, this is 2. What would this be? Did you say 2.5? If you did, you're right. This is 3. What would this be? Did you say 3.5? If you did, you're right. Every tick mark is 0.5. So what I did is since I know that every tick mark is 0.5, I went 2 tick marks to make 1. So 1, 2, 3, 4. The rise is 4. Now the run is doing the same thing. Every tick mark is 0.5, so I have to go 2 tick marks just to make 1. So here I go. 1, 2, 3, 4, 5, 6. The run is 6. So on my slope triangle, rise over run, 4 over 6, I'm going to get 2/3. 2/3 is just the simplest form of 4/6. Because 4 divided by 2 is 2, and 6 divided by 2 is 3. So now I look at the line from left to right. Is the line rising or falling? Well, if you start at the left and you go to the right, the line is falling, and that means that this is negative 2/3. So I've done the first thing. I used my slope triangle, and I found out that from my slope triangle, the slope is negative 2/3. And I'm going to write negative 2/3 right here. Negative 2/3. Okay, the second thing is you have to find the y-intercept. That's where the line crosses the y-axis. So here's my y-axis right here, all the way down. And you see the line, it's red. It's crossing the y-axis exactly 1. So my y-intercept is 0, 1, or 1. Now that's my b value in y equals mx plus b. The b is the y-intercept. It never has a variable next to it. So now I substitute the m in the m spot, mx, and I substitute the b in the b spot, and I have my equation, y equal negative 2/3 x plus 1. So you find the slope, you read the line left to right. Is it going to be a positive slope or a negative slope? You find the y-intercept, and you substitute in the m and the b in the equation, and now you have a linear equation that is written in slope-intercept form. Okay, next, we're going to look at a couple examples that are in your math book. So we have a situation that we know is linear because it makes a straight line. And again, the 2 points that you draw your slope triangle from are already identified. So I have a point right here, which is 5, 4. It's over 5 and up 4. That's this point in the table, 5, 4. And I have another point that's right on a grid intersection line that is 2, 2, over 2 and up 2. So what I need to do is put in my slope triangle, and I'm going to do that now. There's my rise, and there's my run. Now I need to use the slope triangle to find out how big the rise is and how big the run is. So the first thing I do is look to see what they're counting by. Here, every tick mark is 1, so that makes it really easy so I won't mess up when I count this. So here I go, 0, 1, 2. The rise is 2. Now the run, 0, 1, 2, 3. The run is 3. This graph has a slope, an m of 2 rise over 3 run. So m is 2/3. The coefficient or the constant rate of change is 2/3. Now on this one I can't figure out what the slope is because you can't really tell where it's crossing the y-axis. It looks like it's gonna cross the y-axis if I extend the line out, which I'm gonna do now. I'm gonna try anyway. At just below 1, so maybe at 0.8. So if I had to write an equation for this line, I would look at the line to see if it's rising or falling from left to right. Here's left, here's right. What's it doing? Is it rising or falling? If you said it's rising, you're correct. So this is positive 2/3. So that means my equation is y equals 2/3 x. And the b, remember, I thought was about 0.8, a little bit less than 1, plus 0.8. Second one. My points are already identified. My first point that I'm going to use to find my slope triangle is 1, 4. And my next point is 4, 2. So what I'm going to do is I'm going to draw my rise, and then I'm drawing my run. I like to keep saying the words out loud too, because the most common mistake students make is they switch around whether they divide by the rise or the run, and so the more you say it to yourself, the more you'll remember it's rise divided by run. And this is my rise, and again I'm noticing that it's counting by ones, so this is 0, 1, 2, and again this is 0, 1, 2, 3. Now before I write my slope, I have to look at the line to see if it's falling or rising from the left to the right. So from left here to the right here, what's happening to the line is it's falling down. That means my slope is negative 2/3 x. This time it looks like I'm going to extend the line so you can see where it's going through the y. About right there. Oopsies, got it off a little bit. Try that again. Looks like 4.6-ish. It's more than half. So plus 4.6. This is my y-intercept. At 0, y is 4.6. So y-intercept, slope. Remember the slope or the m is always in front of the x. Okay, you are done.